Good morning, everybody. So it's my great pleasure and great honor to introduce our distinguished lecturer today, Dr. Nancy Chen from H-Star Singapore. So she is an H-Star fellow, and she's also leading the Multimodal Generative AI group, and she heads the Artificial Intelligence for Education program at Institute for Infocom Research. And also she's a principal investigator at CIFAR. CIFAR is our partner institute. Then, so she did great research and she has like a lot of best paper awards in many conferences. Like for example, ICAS 2011 on forensics, APSIPA 2016 on education, SIGDIA 2021 on social media, MICAI 2021 on neuroscience, EMNLP 2023 on healthcare, and ACL 2024 on cross-cultural NLP. So that's amazing, a lot of applications of AI. And she's also quite active in doing, organizing conferences and things like that. For example, around our area, she was a program chair for ICLEAR 2023 that was held in Africa.
Yes.
And then, so she will be a program chair for NURIX 2025. So that's a great conference. So today, so Nancy will talk about multimodal, multilingual generative AI, from multicultural contextualization to empathetic reasoning. So the title is quite intriguing. So looking forward to it. Thank you very much for visiting us.
Thank you. Ohayou gozaimasu. Yeah, so thank you very much for the kind words, and I will be seeking a lot of wisdom from Masashi to learn from his experience from program chair of NeurIPS, since he has a lot of experience there. So looking forward to that. Yeah, so today I'm very happy to have this opportunity to share with you some of our ongoing work in generative AI related to multimodal and multilingual aspects. And in particular, we'll look at how to do better contextualization with multicultural considerations with the multimodal multilingual lens, and also how to go into empathetic reasoning so that the human AI communication can be smoother and more engaging. So I'm gonna skip this and I'm gonna start with this comic strip that I read when I was a kid. So apparently it's older than me. So Doraemon has also great wisdom and foreshadowed the era of generative AI almost half a century ago. So here Doraemon shows that, I have this special box. You can put in your special manga that you like, and it can learn the style of the manga artist. And then you can further specify what kind of topics you want, how long or short you want it to be. And then a new manga pops out with your specifications. So this is pretty much what we're seeing now. So large language models has been getting a lot of traction, and it's because it's foundation models' first success story. So large language models are mostly getting trained by text, but now it's going very multimodal. And it's a very generic model that you can easily adapt to different types of task-specific models. So it can power a lot of generative AI applications. So in the past, you need different models for each of them. Now you can use the same model to do question answering, to do sentiment analysis, to know if a tweet is angry or happy, information extraction, image captioning, object recognition, and a lot of these other tasks as well. So before we go forward, I just want to quickly give a brief statement of what has been happening in AI for the past 30 years. So a lot has been happening, as you all know, you're all in the field. And so, but if you want to sum it up in 2 words, it will be emergence and homogenization. And both of these are very, very key to enabling scale. So emergence means that it's a behavior. The behavior of a system can be implicitly induced rather than explicitly constructed. So back then, when you had to build AI models, it was very expert AI systems. I realized I shouldn't move. Sorry. Yeah. So then you need to explicitly construct the rules for each system. But then with the emergence of machine learning, we can implicitly induce the rules by learning how to do something through the homogenization of algorithms. So then the algorithms will figure out the underlying rules implicitly. You don't need to really know what they are explicitly. So a lot of attention has been in feature extraction and engineering. So you might need to know specific domain knowledge to get the right features. So if you work in speech recognition, you might want to take advantage of the properties of the human auditory system, that we are more sensitive to lower frequency sounds than higher frequency sounds. And so you might use a linear scale and then use a log scale afterwards to capture and more align with how the auditory system works. And so then that can be better for your model because your features are more mapped to the domain specific problems. If you're in image, computer vision, then you might need to figure out ways to extract the edges of objects better, because object recognition is a very key task, a fundamental task in vision related work. So that was how things have been progressing, and that was a very big revolution in the 1990s. And in the 2010s, deep learning wave came. And so here, now it's the emergence of features. I no longer need to have so much domain knowledge about how speech works in the human brain, how to extract edges. Now the deep learning network can learn the hierarchical features on its own. And so this was also seen in conjunction with the harmonization of neural architecture. So a very classic example in computer vision is that then people started using convolutional neural networks as the fundamental building block for a lot of tasks. And then 10 years later, just when we thought the AI winter is coming, actually a bigger hype came. So this is the era of foundation models, where now the emergence of functionalities are here. So now you don't really need a specific model for different functionalities. It's all pretty much consolidated into foundation models. And so this is what we're seeing now. And so a lot of this that has been driving it is the language model. And I just want to quickly go through this. A language model, as you all know, is actually a very classic word guessing game. So just now, let's say I came in and someone came in when I'm talking and I was saying thank you to Masashi, and the you got cut off. So usually our brains are able to fill in the blanks because we have a language model in our brains where if it's given these three choices, thank you, thank me, or thank God, in a lot of contexts, if you don't have other information, then the most default one would be thank you. So, and you might speak more than one language, right? So if it's, so you might have a language model for English, and a language model for Japanese. And if you have had more training data for Japanese, maybe your Japanese language model is better. So when there is more noise in the background, it's easier for you to decode and fill in the gaps. So this is what we do as humans. And so this, from a human perspective, it's been with us for a long time, at least conceptually. And I wanted to mention that actually a lot of people feel like, oh, this is a new thing, but actually language models have been around for a very long time, so more than a century. So this dates back to 1913. So in Markov chains, Markov used language models in the statistical n-gram framework to predict in the Russian literature if the next word is, if the next letter is a vowel or a consonant. So this was one of the earliest documentations of language models, and everyone here should be pretty familiar with the statistical machine learning framework. And in Shannon's information theory that underpins all of the digital technology we enjoy today, and we have a lot of that in Japan, also used statistical language models to predict the sequence of English letters. And so these two have been very big driving forces for language models back then and influenced linguistic psychology and engineering. And so a lot of progress has been made at that time, but it got stalled for a while because a very influential linguist called Chomsky came out and said, you know, this is just an engineering hack. So we shouldn't pay so much attention to it. Our brains are so much more sophisticated than that. So this stalled it for a while, but it made a comeback in the 1970s. And actually this time it was a commercial breakthrough. So for speech recognition, both at IBM and CMU, people took great advantage of language models. So the task of speech recognition, these days you might be very familiar with using Siri, Google Home, Alexa, but back then, getting it to work was quite a pain. And so this is because the acoustic signal, when you talk, so when I say, I love language models, and then I say again, I love language models. To you, this is, it might sound exactly the same because the same speaker speaking it in repetition. But these are two distinct acoustic waveforms because if my microphone was a little farther away, if my throat, my vocal folds were a little more dehydrated, or I was distracted and thinking about, oh no, I forgot to add the slide, all of this will change the acoustic signal. So there's a lot more acoustic variation that is embedded, although the underlying intent of the words I want to say are the same. And so using language models, you can take great advantage of the structure of language, where in Japanese language, you do subject, object, and verb. So the verb comes at the back. So not all word sequences are created equal. And then this is, and then in English, it might be subject, verb, object. So you can take advantage of these and use that to streamline how you predict what the next word would be. And so the first commercial application, which you all see a lot today, is that it's a digit string recognition task. So when you need to say your identity number over the phone, they might use a speech recognizer, and now they greatly compress the perplexity from millions to just 10 digits. So each slot is just one digit. And so this is a trick that was used and had commercial success. And so the founders of Dragon Naturally Speaking, Jim and Janet Baker, were behind this. And so this is the story that actually language models have made a very big breakthrough back then already. And then after that, there was a lot of attention in how to smooth these probabilities, because a very classic flaw is that if you've never seen words that happen in the test set, and the training set that occurs in the test set, then it's easy to under-evaluate their probability, right? So a lot of smoothing techniques were proposed. One very classic one is class-based n-grams, where you have a hierarchical structure, where if I know the next word is an adjective or a kind of fruit, then I can take advantage of the parent node's probability and do better smoothing. And so there were toolkits that were used. One of the most popular ones was from SRILM. So I know a lot of these people quite well. So I feel very honored to have witnessed the progression. And then roughly 2 decades ago, a lot of endeavors started to explore how to do this in the neural network space. So Bengio started in the early 2000s. And then there was a lot of effort going into neural architectures like RNN, LSTM, because speech and language is a sequential series of data. So the neighboring words have more importance to you. And so how do you do a graceful trade-off? Because the longer the sequence you need to model, it's going to be slower, and that you would like more context. And so these were different endeavors. And then a very, very key thing a decade ago is vector representations. So before this, NLP researchers were kind of a outcast or oddball in the computer science community, because everyone else's data is numeric. So computers love numbers. It's easy to come up with models to directly use these numbers. But for text, it's a human artifact that's a discrete representation. So there are different, very awkward ways of trying to integrate that into these computational models. But with the advancement of neural networks, people took great advantage of the vector representations in neural networks. So although they're not very easy to interpret from the human brain, it helped the computer do a lot of contextualization. And this isn't new in speech because speech is a physical signal that has numbers. So for speech researchers, they have always used a lot of neural network help, whether neural networks were popular or not, to make the representation richer. But for NLP, this was a very big, great breakthrough. So then that all the other tools that everyone else is using, now suddenly NLP researchers can use it. So this was a very, very big deal to the field. And then in 2017, Transformer also has become a default Lego building block of large language models. And it's because now you no longer need to worry about the trade-offs of speed and how much information or neighbors you model. So you can do parallel processing and dynamically attend to key information that you think is suitable for you in the entire input context. And so this has been another important push. And then as an NLP researcher, I would say that in 2018, when Google's BERT paper came out and was the best paper awarded at NACL, this was the dawn of the large language model era already. So people that are not NLP nerds may not realize it, but this was the time point. And because starting then, using BERT, you can actually very easily solve a lot of language understanding tasks that have been cast into classification tasks to make it easier. And the power behind this is self-supervised learning. So in machine learning, we know that if you broadly classify to supervised learning and unsupervised learning, supervised learning might overfit, but when you compare accuracies, it's very hard for unsupervised learning to be better than supervised learning. And in supervised learning, you need a lot of manual annotation. It's not easy to scale. So the beauty of self-supervised learning is that, but for the field of NLP, text is a human artifact, and actually it's an annotation of language. So we train all these college students and they sit in front of the computer all day to post at blogs and edit Wikipedia. And all of this can be reused in a very resourceful way where I define a subtask to, for example, predict the next token. And I can scrape all the sentences I can find online. And I can do comparisons between word pairs. So if I compare all the neighbor words of king and queen and use the vector representations to do this modeling, implicitly, my model can infer that they share some kind of semantic dimension, and it might correlate with authority, but it's encoded in vector representations. And then they also have a contrasting relationship that aligns with the gender concept. And you can do this for any word pair. So you can do it again for princess and queen. So you'll similarly get some alignment on the authority dimensions of semantics, but you'll also get a contrasting relationship of senior and junior, but you won't have a gender contrasting relationship. So by doing this, this solved the semantics modeling problem in language that has bugged people for a very long time because it's so subjective and so hard to grapple. But here we can use an implicit and resourceful way to model it. And so it took on. And so any language understanding task, you could use something like BERT and it worked really well. So then more models came out that help with generation tasks like BART. And this is actually when GPT came out, but at that time, no one cared about it. But so a lot of models came out at that time. And ChatGPT had a very friendly user interface that came out in late 2022. So then now outside of the NLP nerd world, people realized, oh, this is interesting. This is not so hard to use. And it got a lot of traction and interest. And of course, we know a lot has come on, and there's Gemini, there's GPT-4, it's getting, so everyone talks about it, whether or not you were originally working on things like BERT or vector representations. And so I just want to bring this up. We might see a lot that was happening a little more rapidly recently, but actually, to someone that has been working on this, this is not an abrupt thing that suddenly happened. There's a lot of buildup that has been happening for the past century that has led to this step, and it's actually more gradual than how it appears on the hyped media. And it takes all of people's work, like you and me, to make the field move forward. And so just wanted to share this. And then start talking about, so right now, some of the work that we're doing. So in the generative AI capabilities, you can make it into 3 parts. The first part is pre-training. So it's similar to a person reading a lot of books. You want to accumulate a lot of fundamental knowledge. And then the second part of instruction fine-tuning is when you're converting all this knowledge to task-specific skills. So after you read a lot of books, let's say now I want to hone my skills for public speaking. So I need to convert all that knowledge I have into different types of skills for public speaking. And then for alignment post-training is a human-centric adaptation. So where I'm giving a talk, whether it's in Japan or Turkey, I'll need to align it a bit. So I did do some alignment, and I'll have to do some in-context learning today. So if it's wrong, please bear with me. But yeah, so this is the human cultural values adaptation part. So these are the 3 parts. And with these 3 parts, you can build up a generative AI model. Then it's quite generic. So you can easily use it in different types of downstream adoptions. So, and when you use it, you may not need as much domain knowledge, but you need to do it right in the right in-context learning, the right prompting. And this can enable a lot of users to take advantage of it. So some of our users and clients are government agencies. It could be commercial spin-offs and big companies that want to start using AI because they haven't in the past. So here I wanted to show Merlion. It stands for Multimodal Empathetic Reasoning and Learning in One Network. So this is our generative AI efforts in Singapore's national LLM program. And I would like to check how many of you feel comfortable with your kanji or understand Chinese characters. So I'm going to use this to allude to how our different parts of the Merlion system is. So this is the traditional Chinese character of listen, and it's made up of different parts. So the red part is the ear. So it's for hearing. Okay, so this is where the speech and audio input is encoded. But the blue part has the eyes. This eyes is a little turned around. So when you are told to listen, at least in the classic Chinese sense, you should also be very attentive and pay attention to the person talking. So you should look at the person. So the visual inputs could be important. And then you can do multimodal integration. So that's the purple part. And then for the decoder, we have 2 parts. One is the analytical side. So it might decode the semantics. So this is more of the thinking brain. But we also want to emphasize your heart. So the orange part is the heart. So you also need to feel and understand the feelings of others. So this is the empathetic part. So a lot of times the information of the feeling and emotion part is not in the text. So it's in the intonation of my speech. Okay, how the speech goes up and down. It's very subtle, but humans are very sensitive to it. And so we want to also capture that and do the reasoning together. Okay, so this is the basic gist of the different parts of Merlion. And Merlion, I will talk about some examples. Okay, so here I want to give some examples. I'll give some Singapore examples and some Japanese examples. So we want to do end-to-end multimodal large language modeling. And so current systems, if you make it cascaded, there could be error propagation. So I'm going to use a speech example. So this is a Singlish sentence, so I have to explain to you what it means. So here it's, Bojo, you went to the movies without me. So Bojo is a Singlish term. It derived from Hokkien, which is Old Chinese, and so sometimes it sounds similar to Japanese and certain words. But here it means like, oh, you didn't ask me, you didn't ask me to go with you. So it's the fear of missing out. And it implies a social relationship you have with the person you're talking to. So you have some kind of intimacy so that you say, bonjour. Then next time the person will feel very embarrassed if they don't bring you along to the movies. And so there's a little bit of this passive aggressiveness of saying, oh, why didn't you bring me? But in a more socially reasonable way that's easy for people to find it humorous and easygoing. So, but if you insert this speech utterance into any speech recognizer you find, it will always give you, bonjour, you went to the movies without me. So it's a completely different meaning, okay? So if you lose this pink word and get the green word, that meaning is lost forever, okay? So then you can do a lot of things afterwards, but you'll never recover that. And so here we want to fix that. And so here, okay, I learned Japanese for 2 months, so my Japanese isn't very good. So this is my best attempt. So let's say, I say, kawaii ne. So this is different from kawaii desu, right? So when I say ne, it kind of invites you to come and agree with me that, oh, you also think it's cute, right? So it implies this social interaction that I'm trying to seek some approval from you or some acknowledgement from you that you also agree with me, because I think you'll also think that way, and I can bond a little bit with you and we can enjoy how cute Pikachu is together. So this pink character, or this pink, I guess it's letter, Japanese, is a similar thing where there's a lot of spoken paralinguistic nuance encoded inside, and there's social implications. And when you express it in spoken form, a lot of the acoustics characterize that. And to the human ear, if you're culturally sensitive enough or aware of it, it will be very salient to you. So these are the things we want to model. So when a speech and audio signal come in, we can think of it as having 2 types of information. So one type is the semantic information that aligns pretty well with the text and the vision part. But then there's also this part that is expressed through your voice qualities that gives you clues of the social dynamics, clues of your mood that we also want to model. And so together with this can make a more comprehensive understanding of the entire situation. So from the audio scene, I'll give some examples, voice characterization, and then also the language understanding of the conversation semantics, and you can take into everything in more context. And so you can minimize errors and empower more applications. So I'm gonna, okay, so here,
by the way,
oh, sure.
Left, so you had the signal, the speech and audio representation. So
yeah.
You have signal, and what's the one in the bottom?
Oh, that is just the representations on the text side, the semantic side. So it's not. I didn't have a good way to represent. It's not a, yeah. So the speech signal is a physical signal, but the others is more of a representation of the neural network part, that modelings that are not easy to understand. Yeah, so sorry for, I wanted to put 1s and 0s, but thought it wouldn't. Yeah, so I'll try to see how to make it more clear. Yeah, so sorry about that. Yeah, so it's just the semantic representations that are not so easily understandable, but the neural networks are using it. So here, the capabilities we're building, we want to answer the questions from what to why. So we can detect what sounds are being made, but we also want to ask the questions of whys. So I'm going to show an example, and it's a little intentional that the video is small because I want you to focus on the audio. Yeah, so you might hear a little bit of water flow and it gets louder, and there's also birds in the background. And then as the water gets louder, finally, you hear some like wood, like dropping sound, right? So you can detect each of these audio sounds, but in this sequence it implies that this is in the outdoors because there's birds singing, but to an animal like a bear, it might imply that humans are around because this is what humans do. They use tools to deal with water. And so I'm quite fascinated by this concept. So it's like a scarecrow using audio setup to let the beast don't come. Right, so this is the Japanese concept. So if you have an audio like this, you could infer a lot of things. You can infer this more likely happened in Japan. These are not random sound sequences. There's actually a very ingenious technology and history behind it. So this is what we mean by audio scene understanding. So in addition to detecting the physical sound, you can further interpret the physical sound sequence and give you more contextualization of the acoustic environment, the setup, whether humans are involved or not, and what is the intention of this setup. Okay, so this is one example. So from the audio side. So for the other parts that we're trying to establish is through voice characterization to spoken language comprehension and the contextual reasoning part. So voice is a special kind of audio where you're using your vocal folds to generate sound. And when you're using it to communicate, it's speech. And when it's voice, it can give you a lot of information of your gender, your age. In Japan, there are many different accents. By how someone speaks, you can figure out where he's from or grew up, and also the emotions. So here, I'm gonna play another video to demonstrate some of these aspects of the 3 other parts.
What did you say?
Are you being mean to me?
No.
No? Are you happy?
Yeah.
I need another mommy.
You need another mommy?
Yes.
Okay. Who do you want as your mommy?
Auntie Chen.
Okay. I'll tell her.
Okay, mommy.
But you can't call me mommy anymore.
Mama?
You can't call me mama.
What's your name?
Michelle.
Michelle? You're not Michelle.
Are you ready to go now?
Yeah,
Okay.
mommy.
So in this short clip, we could hear 2 voices, right? So you could infer one is a younger person, one is an adult. And you can ask very factual questions about it. So what is the mother's name, the adult's name? It's Michelle. Who does the child want as her new mother, Auntie Jean? But you can also ask how the emotions progressed. Or you can ask, so in the end, did the girl want a new mommy? So what was happening? So the child was very upset with her mother. So when she said she wants a new mommy, actually what she's trying to say is that, mommy, I feel like you're not listening to me and I feel hurt. So I'd rather have someone else that can listen to me. But then when the mommy says, okay, then you'll have a new mommy, you cannot call me mommy anymore, she's very confused. But the mom has always been very calm in this conversation. So that made the child actually not upset with her mother anymore, right? So she got very confused. Why can't I call you mommy? And you're not Michelle. That doesn't sound right. You know, emotionally, you're not some random person, Michelle. You're my mommy, And then I can't call you mommy, so I should call you mama. But yeah, so then in the end, she made peace with her mother without knowing it. And so this is the empathetic reasoning that we would like to be able to interpret. So if the AI agent is able to do this kind of empathetic reasoning, then it can be very, very beneficial for a lot of human AI communication. And we will show some of the examples that we've been doing in the education space to teach children how to speak different languages. So here are some of our work that's ongoing. So this includes Audio Bench, which sets up benchmarks for this. CEVAL is what I'll talk about a little more. It's more on the multilingual side. And then I will show some of the technology demos for the empathetic reasoning part applied to education.
The task of empathetic reasoning is not so clear to me.
Yeah.
Given that video clip, what's the real task?
Okay, yeah. So then we make it sharper in the applications where we need to figure out how to engage with the child better. So it could be how you ask the questions in the context of learning. And so if you detect that the child or user is not doing well, it could be because that the child is not engaged, not interested, or because the child really doesn't understand, or both. So we try to do some implicit understanding of these different aspects, and then discuss with the education experts on what are different strategies to resolve this. So yeah, and then we might need to have different trade-offs on the technology side as well. So yeah, so the task itself can be decomposed to different types of understanding that includes the emotional aspect. But then when you make the final decision of how you want to generate the response to engage with the child, we also have to merge in different aspects. Some are not from the technical side. Yeah, so does that make it clear? Yeah. Thank you for bringing it up. Yes. So yeah, so a lot of these are cultural aspects. So you can think of your younger generation also has a different culture. But here, a lot of times the first order of approximation of culture is language. So, and it's because only humans use language. And so a lot of the customs that we have or preferences that we have from a certain group is embodied in the language. But we also use language to conduct our reasoning. So in that sense, these three are different concepts, but they intersect because we often use language to communicate as human beings. And so I'm gonna use an example, a Japanese example. So how people have tea and coffee is could be very, very culturally different. So the default of what tea means in Japan is green tea, but in other places it may not be so. And so in some cultures, you embody other parts of your philosophy of life within it. And so this is one of my favorite quotes. And so I thought to share it. And so then I'm going to show an example from Singapore side. And Singapore is a different kind of society with different cultures. And so when you're ordering coffee, it could be a bit different.
Can I get a kopi kosong?
There's no kopi kosong. Kopi is with condensed milk. Kopi siu dai has less condensed milk. Kopi C has evaporated milk and sugar. Kopi C kosong has evaporated milk and no sugar. Kopi O has no milk, only sugar. Kopi O kosong has no milk and no sugar. You understand? So there's no kopi kosong. What you want?
Coke.
So yeah, so if you didn't understand this English, that's okay. So you're just as smart as ChatGPT. So I wanted to bring up what we're doing for cultural reasoning. So here, I'm going to bring your attention to if we ask this question, what drink in Singapore has the highest calories? There's a lot of Singapore lingo here. And so you need to do multicultural reasoning. So the first step is the multilingual understanding. So de is actually the original word for tea from Fujian province in China, and the British brought it to around the world. And then shou dai means less amount of sugar. So it's from Hainanese and Cantonese. Kopi is from Malay. It means coffee. It has Arabic roots. And how you drink your coffee and tea, there's different preferences. So in Singapore, because it has a lot of westernized adoption of customs, so when you say day, it's actually tea plus condensed milk plus sugar. So that's the default of how tea comes in. So if you don't want as much milk, you need to further specify it and say day o. So the o means subtraction, subtract out the milk, because o means black. So when you have less milk, it's black. Kopi, similarly, is coffee plus condensed milk plus sugar. So if you want it to be more diluted in terms of the milk, then you have to add a specification. So C is similar to the sound of thin and diluted in Mandarin. So then Kopi C is coffee plus evaporated milk and sugar. So then the third step, you need to do reasoning with dietary knowledge. So condensed milk means it's sweetened. There's sugar involved, and sugar means there are a lot of calories. So if you, depending on your diet needs, you might want the highest calories or the lowest one. And so you need to go through these steps. And so we compiled a benchmark that takes into consideration the different types of cultural comprehension tasks that I just mentioned. Some of them involve reasoning. We also look into cross-lingual assessment. So right now, the languages that we have compiled include English, Indonesian, Malay, Chinese, and Vietnamese. We're expanding it. And so we start with the Southeast Asian base, but can go beyond, and look at tasks. In addition to standard NLP tasks and complex reasoning, we also look at cultural understanding and cross-lingual consistency. So here, through this, we want to understand the boundaries of multilingual large language models. So we'll look into these 4 parts. So the first one is when instructions are paraphrased, how consistent are the large language model's answers? So usually when you think of accuracy, you have a number, and the higher it is, the better the performance. And so you would expect if you gave the same instructions that meant something semantically the same, the behavior would be the same. But in reality, this is what we see. And so here is one example where you could see that for the horizontal axis, you have different prompts that mean the same thing, but it's worded differently. Then the performance of the different types of language models could vary, and more parameters does not mean it's more consistent in performance. And so these are some qualitative examples. So you have the exact same instruction in bold. Please select the correct answer for multiple choice question. Please choose the correct answer from the options provided in the multiple choice question. And then the question and the multiple choice options are the same, but one you get it right, what the other you get it wrong. So this is another example from biology. And so we see this is not consistent with in English instructions. So now when I go to the multilingual part, if it's a factual question, we would expect that using a different language shouldn't change the answer. So this is what we expect, but in reality, we see something different. So this is one example, it's a physics question. So please choose the correct answer for the following question, when white light passes through a prism, the light that bends more than green is which color? So the correct answer is blue, but when we change it to Chinese, Indonesian, and Spanish, the answer is wrong. And then for Thai, it's wrong. French and Arabic, it's correct. So Vietnamese, Portuguese, it's right. Tamil, it's wrong. So here we want to look at accuracy from a more comprehensive perspective of looking at semantics and multilinguality also at the same time. And so this is a more realistic picture of how we might want to characterize multilingual large language models, where the green axis is the paraphrase instructions. The orange axis is the multilinguality part. So each color is a different plane, a different language. So you can see green is English on top, but it's not flat. There's a very big gap between green and red. Red is Mandarin, so it's pretty bumpy, followed by...
What happens if you translate the Mandarin into Chinese, a question in Mandarin, English, and ask the question in English, then obtain a solution in English, and then translate it back to Mandarin?
So...
If the translation is almost correct, I think you can get the perfect answer.
So here, yeah, but here, oh, so you're saying if you, instead of directly asking, yeah. So if the translation is correct in the English part, it might be, it could be, So, but if you directly use Mandarin, this is the direct one. But if there are different ways. Actually, we haven't published this, but we are looking at deeper questions of this where you take advantage of thinking, the reasoning in a different language, and when to do that is better. So it does help address some of this. So we can discuss more on that. So this is a direct usage of the models out there, and we see that it's pretty bumpy. And so after Mandarin, you see Spanish, Indonesian, Malay, and this is an example for logic questions. And so part of what we're doing now is to try to address this so that it's more balanced and all ideally as equally good as possible. So this is what we see across different types of models. Some are more Western oriented, some are more Asian oriented. And the idea here is that accuracy is the standard thing we look at, but when you look at consistency, so here the green bar is consistency. So if it's a higher bar, it means it's consistent. It can be consistently wrong. It'll still get a higher bar. And then the red one is the harmonic mean between accuracy and consistency. So the idea here is that it's not very consistent. So across languages. So this is for understanding tasks. And then when it's logical reasoning, it's the same trend, but all the bars numbers go down. And here I wanted to show you the spread of inconsistency. So these are across different tasks. So the error bars show the deviation that it might range, that it might have across different tasks. Some are understanding, some are reasoning, some are machine translation. So this is not as robust as we like. And so here I also wanted to just quickly mention that even very simple tasks like this shows that there's bias in these models, even when you introduce new tasks. So here we have test sets that are compiled by others. So if you directly use it, you get the diagonal bars. So whether it's a new task like cultural understanding that we just showed, or a more classic NLP task of sentiment analysis, you'll get the stripe bars that are higher. So now, if we just shuffle the options in the multiple choice, then they always go down. So you see this across different tasks. So we don't know why or how it's coming about, but we know that that means that there are biases in the model that are contributing to it looking like it performs well. But how to disentangle that is a bigger question that we're also looking into. So in general, one point that we want to bring up is that it's very hard to find balanced multilingual large language models. We don't really see it right now on the different tasks, whether it's understanding and logical reasoning. And some classic problems in machine learning still happen. So catastrophic forgetting still happens. So here is just to demonstrate when you're adding in new data that is chat data that's different from document data, you can see it performance always drops. So these are not new machine learning problems. It's still around, and we could work harder to figure out how to better address it. So these are the summary of the key points of this part of the multilingual aspects that I just mentioned. And then I wanted to give some examples on on some technology that we've developed. So we've been applying the model to also different domains from security, education, transportation, and healthcare. So some of them are collaborating with industry or government. And so here I'll just use one example on the education side. So in Singapore, we have 4 official languages: English, Malay, Mandarin, and Tamil. So everything official is in English. So government, education, law, business is in English. But the other 3 official languages were chosen because of the multicultural setup of our Singapore's heritage. So at school, as a child, you have to choose one of these 3 ethnic languages that are closest to your ancestors' language, and also take several hours a week to learn it. So when Singapore was a newer society, at home, you might still use a lot of these ethnic languages, but for the past 2 decades, all of this has been dropping. So it's been converging to everyone's using English, whether at home or not. And the Singapore government is worried that people in Singapore will lose their bilingual edge. So that has actually helped in a lot of good business opportunities and political relations. So using AI is one way that you can scale the support for the personalized needs of teachers and students. And so Confucius said, 因材施教 means you should customize your teaching to the pupil. And so this was a concept that was well known 2,000 years ago, but it's been very hard to scale because it's such a manual process. So with AI, this can definitely help. So here I wanted to show one example that we have developed where it's focused for children in primary 1 and 2, so 7 to 8 years old, for them to learn the ethnic languages in Singapore, so Mandarin, Malay, and Tamil. And so we wanted to have the model needs to be compact because we need to, there's a very lean budget on how to operationalize and deploy it. And so one model needs to work on all the languages. So here, the horizontal axis is the English capability. The vertical axis is the multilingual capability. So this is on language understanding and reasoning tasks. So we benchmark it. So ours is the pink bubble of EDULM. So the size of the bubble is the size of the model. So we can see that compared to models similar size with Chen, our multilingual capability and English capability is a little better. And then we also can compare with bigger models in Neta, Slama, and Qianwen, and where our model size is more compact. So here is the ideal spot we want to go to. So we want the capabilities to be as good as in English and in all the other languages. And so this is the gap we have, and we're working on it. So similarly, for language generation, we can do a similar thing. So and do a similar benchmark and strive for perfection to reach the ideal of being good at all languages and have as small a model as possible. So yeah, so here I guess I answered Masashi's question about the empathetic reasoning. So this is a summary. So where we want to provide more scaffolded guidance when the child is learning, and by detecting the different types of emotions and cognitive and non-cognitive abilities, then we can provide a better response from the tutor's perspective. So here's one example that we ran into when we are making the AI more multimodal and multilingual for children to use. So in these cases, the children are very used to speaking in English all the time. So for example, their Mandarin isn't very good. So when you ask the child to speak in a language they don't really understand very well, the most likely response is they don't want to talk. So a very key thing for the AI tutor is to encourage the child to talk more. And so one way is to be more inviting and ask with tag a question. So in English, you might say, hey, this is a lantern, isn't it? So this way of speaking, you indirectly mention this is a lantern and you're asking the other person to agree with you. But when you directly translate to Mandarin, 这是灯笼不是吗? In this cultural context, in Mandarin, it sounds like scolding. It sounds like, what? Why would you not know such a simple concept? So then your good intentions is lost in translation because it came out actually the opposite way of what you intended. So in English, you might change it to, this is a lantern, right? So this is pretty similar to the other English sentence. This is a lantern, isn't it? But when you translate that to Mandarin, 这是灯笼对吗? Then it feels more encouraging and supportive to make the child feel more comfortable to speak more in Mandarin, which is a language that he is less familiar with. So we found similar patterns of these in Malay and Tamil that are more westernized. And so we've been addressing this in a more direct way of, instead of going through a more explicit translation step, if you directly model the language, it tends to be less westernized so that these nuances would not get lost. So, and this has helped us contextualize these multicultural factors better and to give more engagement in these systems. So, and here I just wanted to point out, so this might be a picture that is shown to the child. So so here the text is, the family consists of 2 adults and 2 children, all wearing traditional Malay attire. So the AI is supposed to know which part of the picture this text is referring to, so it's easier to engage with the child. And so cultural factors include age, gender, and ethnicity and religion. And so here, unfortunately, if you use a model that's not taking into account all of these factors, then the dad or the daughter might be left out of the family. So this is something we're working on. And so here I will like to show an example of this AI tutor. So it's a small model size that helps children do picture description tasks. I heard some people spoke in Mandarin, so I thought maybe I'll just show the Mandarin example, although not everyone will understand it. But please let me know how you feel the conversation flow is, even if you don't understand the semantic part.
小朋友，我们来看这张图片。你看到左边有一个男孩在做什么吗？
男孩在哭。
很好，你知道为什么男孩在哭吗？
他好像摔倒了。
对，他可能摔倒了。你看，他的姐姐在做什么呢？
我看不出来。
没关系，我们再仔细看看，姐姐的手在男孩身上，她的表情是怎样的？
他很难过。
对，她很难过。姐姐在做什么让男孩不难过呢？
姐姐在安慰他。
非常好，现在我们来看右边，你看到那个女孩在玩什么吗？
滑梯。
对，她在玩滑梯。你觉得她的心情怎么样？
小女孩看起来很开心。
对，她看起来很开心。你能再说一遍开心吗？
开心。
太棒了！今天我们学了3个词：安慰、滑梯和开心。继续努力哦。
So previously, when we had the first couple prototypes out, people complained that the voice was too old, that the children won't be engaged. So we changed into a more animated and very energetic, engaging voice. And so very enthusiastic. And it so for people who didn't understand the conversational flow, it basically asked about different parts about the question. And the little boy is sad. So, you know, elder sister is comforting him. So comfort is quite a hard word for children this age. In Singapore for the Mandarin word, and then also being able to detect that the girl on the slide is happy. So these are some of the aspects. And so we also did this for Malay and Tamil, but I assume there are fewer people that might understand these languages, so I will skip it. And so, yeah, so we also apply it for AI for science. So this is to explain how the rainbow is formed. So I guess maybe we are running out of time a little bit, so I will skip it, or do people want to hear a little snippet of it?
Yeah, good.
Okay. Yeah, so this is a little longer, but I think we can hear a little bit.
Hello. Let's think about how a rainbow is formed. We know there is both rain and sunshine when we see a rainbow. What do you think happens to the sunlight when it hits a raindrop?
I don't know.
That's okay. Let's think about it together. When sunlight enters a raindrop, it's like the light goes on a little adventure inside the raindrop. What do you think happens to the light inside the raindrop?
The light disappeared.
Not exactly. The light doesn't disappear, but it does change. What do you think happens to the light when it enters the raindrop?
It's too difficult. I don't know.
That's okay. Let's simplify it. When sunlight enters a raindrop, it bends, which is like curving or changing direction. Inside the raindrop, a light breaks into many colors, like when you use a prism in science class. Can you think of why we see different colors instead of just one color?
Ah, I got it. The light bends in the rain.
Exactly. The light bends inside the raindrop and each color bends a little differently. This makes the colors spread out into a beautiful sequence. The colors are red, orange, yellow, green, blue, indigo, and violet. Since you've understood how the colors separate, can you tell me why the rainbow has an arc shape instead of being straight?
Because it's behind the tree.
That's not the reason, but it's a good guess. The arc.
Yes. So you get the idea. So when the child doesn't get it correctly, the tutor doesn't directly give the answer, but tries to guide the child in the more appropriate direction. And so there's a lot of interaction and back and forth. And so these AI tutors are much more patient than me. So when I'm with my children, I'm not this patient. So this is pretty helpful.
Is it a real-time demo?
This one, this was we recorded the video real time, but it's hard to play real time, so you put it in a video. Yeah. So yeah. So and then right now, for the language learning part, test bedding and user studies are being conducted in the primary schools in Singapore. Yeah. So I think this, yeah, so the key points that I wanted to share today is that we are establishing benchmarks for multimodal and multilingual large language models. So these include contextual understanding, cultural comprehension, and empathetic reasoning. And so some of these efforts include audio bench and CEval. So CEval came out a little earlier, and audio bench we're establishing it. And so shared some observations and insights after we did more rigorous studies that for a lot of multilingual large language models out there, they actually don't have balanced multilingual capabilities and still suffer from classic machine learning problems we've known from day one, such as exposure bias, and they could miss cultural nuances. So in our effort, in the Malayan effort under Singapore's National LM program, we are trying to complement these semantic understandings with multimodal representations and starting with speech intonations and acoustic cues. So this gives us more contextual reasoning for the social dynamics. And we used one example, case study of Singa kids to demonstrate that it is feasible to have more balanced multilingual capabilities and embed in empathetic reasoning and understanding so that when we teach children how to speak another language, it's possible to do it this way. And the model size is compact and needs to work on all three languages, which have different linguistic resources. So Mandarin is a little more well-resourced, Malay is less, and Tamil is a lot less. So on the Tamil side, when we trained it, it was like pre-training from scratch to some extent. So to build up so that they all three can have a more similar performance is something we're working on and have been improving. And so we want to do a lot more. And so if there are any opportunities to collaborate, it would be great. So these are some snapshots of some recent publications and preprints in 2024. So they're related to multimodal large language models. A lot of them are focusing more on the audio and speech side because there are a lot of localization that can be integrated in. And some are applied to evaluating the speech and pronunciation. We've also been working on multilingual and multicultural large language models. So I shared some examples. And so these take into account different cultural factors and how you prepare the resources in a very scalable way to do better instruction fine-tuning, for example. And then some of these touch upon how we apply it for code switching scenarios. So in Singapore, this is very common. And when we're teaching another language, the child might speak in English. You might encourage to speak in Chinese, but it's a very delicate choice. Sometimes you really need to switch over to English for certain words or else the child won't understand you because his Chinese is too weak. So there's a lot of nuances in how to decide the code switching and the generation and how to train that. And also on the empathetic reasoning and generation side, a lot of our work has also been integrated into the speech generation part. So after you do the understanding, then how do you generate in a way that can more easily build rapport with the child? So we're looking at both the understanding and generation aspects. So here I kind of summarize some of the ongoing research directions. A lot of it intersects with what I talked about today. But in general, I hope I brought the message across that I think a lot more machine learning efforts should go in so that we can have more streamlined neural representations so that it's more generalizable and you won't see so much inconsistency and so the balance between multilinguality and scalability is something we're investigating. And I think ideally it'll be really good to infuse some theoretical underpinnings to better robustify the interpretability. And I know a lot of you here have very strong mathematical backgrounds, and this could be something to discuss. Right now, the field is a bit empirical and it's been working really well, but it'll be good to solidify the theoretical foundations a bit more to make it more principled. And then so for the evaluation and benchmarking part, we're trying to do a more comprehensive assessment of the boundaries of the current capabilities so you know where the gaps are. So sometimes when you move to multimodality, like in text, everything's fine, but when you make it spoken, we realize a lot of issues pop up. So one is, of course, there's less data, the data is harder to acquire. It's more informal and there's a lot of nuances in the signal. And so a lot of things you took for granted that, oh, a passive voice structure should work, but when it's in spoken form in Malay, no LM out there can do it. Then it's only when you explore and try out and find out these are the problems, and you can go back and think about what are more principal ways to make it more generalizable. So a lot of our work is in the human AI collaboration space. So we showed some examples in the education part where you can better engage the child. And so we are also, in addition to language learning, looking at math and science and health and well-being, so mental health aspect. And so a lot of times we also need to make the models smaller so it's easier to be used, and robotics could be one application. And the other is, so a lot of what we've done, we think this experience in getting the models to understand language, which used to be a thorny topic, we can apply it to advance other areas as well. So this could help with scientific discoveries where you can scale up the hypothesis generation in a very resourceful way. And this could potentially speed up scientific exploration. So I think the key is how to do it at scale and resourcefully. And so there has been some successful efforts on the speech and language side, and really happy to see how to cross-pollinate. So I guess that's pretty much it. So it's been a longer talk than expected, but thank you so much for the patience in the interruption. And I can very proudly say that this might be one of the most memorable talks because it had so many technical hiccups for you, so you'll never forget me. Okay, so I guess any questions from the room, or if people are still online? Yeah, I know it's lunchtime, so people might get hungry.
Okay, thank you very much.
I'm wondering, have you tried to use it for the mental disorder people? Because now, like in the schizophrenia, depression, and also the AD, we can tell that from the very minor sound difference will result in can be an early diagnosis of the biomarker for the early diagnosis. Since especially you are doing the children thing, do you think that this can be also applied for the lifetime evaluation and warning for the AD and schizophrenia?
Yes. So thanks for mentioning that. That indeed is something that we are thinking about and trying to make some progress without getting too deep into some of the, sometimes there's the confidentiality part of the data comes into play. So we're trying to do some of the technical assessments first. And so this is one reason why we chose education where it's less sensitive, but definitely you're right that the voice characteristics could be very telling on the mental state of the person. And so actually, when I was a grad student, actually I was a consultant for a startup that worked on this exact problem, but nowadays the technology has advanced a lot. Not only can you detect, you could also potentially better engage with the user. And a lot of times you might need to be very patient, and it needs to, these are very into, very case by case. So AI does have a good potential to help more people on this. And so this can also apply to older folks. So in aging societies, actually a lot of senior citizens might have depression or different types of like memory loss and Alzheimer's. And so these Alzheimer's might be very challenging, but these could start some of this to help some of these efforts. So that's definitely something we're interested in and trying to do more work on as well.
Okay, sorry. Thanks for the comment. So I have a consequent question regarding this. Since you're doing the children education, then do you think that this method can also be used to evaluate the children's potential, the futures, like the learning ability? Because Singapore is very known for the staging people, like the separating people at the very earliest stage. For example, when they were 10 or 12. So do you think that given like the multimodal method, your method can also be used to evaluate or predict their potential? And then if we just like predict based on this rule to like separate the people in the very early stage, then of course there will be concern. So have you considered any like potential ethic concern, especially its usage in Singapore?
Yeah. So I think the ethical considerations have been taken very, very seriously. So actually that is one reason why the models need to be very balanced in the multilingual capabilities, or else you don't want the technology to favor certain groups than others, right? So that's something where that's one reason why we work on languages that are more from the minority groups a lot, because it is from the ethical aspect. And so I guess I'm not an educator by training per se. But I know there's the stereotype that in Singapore, maybe children are put into different streams a little earlier. There's a very important exam when you're 12 years old. But I think things have changed a bit, where it's becoming much more comprehensive in the evaluation. And some of these, so in that sense, it's similar to LM, where we want to do a more comprehensive assessment. And so in that sense, when you're setting up these benchmarks, right? So one thing that we often worry about is if your benchmark is too simplistic, you can easily overfit and cheat and do well on the exam and look like you're very good. So there might be aspects that are missing in the benchmark. So this is one thing we're doing to fill in the gaps, so that some of these inconsistencies may not have been discovered. So we want to bring it up. Some of these cultural factors may not have been thought of. So we want to make the assessment of the LLMs a little more comprehensive. And I think this could benefit the human part as well. Of course, we're very cautious to make sure that it starts with helping with the learning as trials first before it is used for assessment, because assessment is very, very sensitive, right? So you want to make sure you can adopt it in daily life, and it becomes part of the teaching and learning process, and you get a lot of feedback on how it works and how it doesn't work before you formally make it part of the official assessment process. So from Singapore's perspective, I think I cannot speak for the stakeholders. I'm only a researcher, but from my interactions, I know they take it very, very seriously. So that's why some of these are slower and very exploratory to figure out if we're doing things in the right direction, in the right way.
Thank you. One question.
Oh, okay.
So how do you mitigate the catastrophic forgetting during training PEFT? What was
PEFT? So this has been an interesting investigation in general. So we have a lot of experience and a lot of trade-off decisions in general, because when you want, for example, if I want my module to be more multilingual, then you need different sources of training data. So when do you introduce the new language? When you introduce it too early, you may not have enough data to make the semantic representations more solid. But if you introduce it too late, a lot of the nuances are gone. So it's a question of the amount of data, the quality of the data, the amount of resources you have in terms of compute, and also in some cases, you might have a sharper application use case. Then you could be more focused on making sure that part is more prioritized first. And so when you have these considerations, then it could help in making sure that forgetting goes less. So you might need to take it in a more, it's not just one single technique, you might need to consider with all these factors. Yeah, but if there are interesting ideas of how to better resolve it, we're definitely interested in hearing. Yeah.
So can I also ask a question? So I was quite surprised to see that demos are really working in empathetic reasoning and also AI for science. So that's really wonderful. But on the other hand, I saw some movie from like human robot interaction people, and it was really shocking. So children are really attacking robots if they are walking around. They really kick robot and punch it. It's really dangerous. And also like for AI for science example, maybe children could ask some nasty questions, like insulting words or something like that. So if you really implement these systems in the real world, how do you avoid that kind of problems?
Yeah. So right now, what we're doing, okay, so on the more deployment side, it's a very simple task of picture description. So I guess we haven't had these cases where the children might speak in more abusive language, but okay, so before the deep learning hype, or during the deep learning hype, before generative AI became very hot, when you talk about, so all these banks might have chatbots, right? A lot of companies have chatbots that may or may not work very well. And so if you look at the data, a lot of times you could see the very dark side of human nature. They could harass I mean, they might think that, oh, it's just a computer. So they might say very filthy things. So this has already been ongoing, I guess. And so it's just that in the past, maybe only people who have access to that data know more about it. And so it's not a new problem in that sense. So yeah, so I think these are interesting because some other disciplines might talk about, the rights of robots. And then I guess one problem where we still face is the technology might be somewhat mature and made a lot of advancements, but can we make a robot legally responsible for a car accident or, giving the wrong medication? So those are the harder parts that I think will need a lot of different types of experts to sort it out. So here we are only from the technical side, exploring the space to understand what are some considerations and doing it in a very gradual and mild way. So right now, I guess from a language learning perspective, if the child is able to curse in Mandarin, we will take that as a positive thing that the child is learning, that at least knows these are bad words. So someone says it to them, they will know. So that's in some sense a good thing from the technical perspective or the language learning assessment perspective of knowing that they know something about the language. But of course, how to educate them to speak more properly is actually something that we have discussed. And so the different experts have different opinions. So when we decide which one goes into the AI model, also need to consider a lot of different aspects because even the human experts sometimes don't agree. So that's one dilemma from the technical side. So how do you take that into account and make a prototype that can kind of work and not have some extreme situations occur in the beginning? So
thank you. Yeah. So then the last quick question is, so how do you make the model compact?
Yeah, so we had to kind of so we did a couple of things. So we one thing was to really prioritize on the deployment use cases so that the information that might be needed there can be more prioritized. We tried different things. So some of it was originally we had internal machine translation modules that are also LMs to help bridge the gap to use English as the base, but realize that actually makes the model too big because then we have too many components. So we kind of had to make the model more generalizable and directly use that specific language but at the same time, we had to try different things to train it so that the representations are more in sync, which right now, because a lot of things are more empirical, so we're still trying to formalize to make it easier to replicate.
Okay, so it's done. So please join me to thank Nancy for the great lecture.